Good afternoon. Welcome to Hydromantis webinar. Today we will be talking about our new release of Toxchem version 4.3. My name is Rajiv Goel and I'll be conducting the webinar. I have my colleague Spencer Snalling here who will be updating you some of the activities we are doing at Hydromantis after the webinar. First of all, to give you a little bit of introduction about Toxchem for the people who are not familiar with the Toxchem tool. Toxchem is a tool basically to estimate the volatile organic compounds emissions in the airstream from the wastewater. For a given influent stream of VOCs coming into the wastewater, you can make a wastewater treatment plant layout, and in each unit process, different mechanism of VOC, degradation, biodegradation, solid liquid partition, or liquid partition and volatilizations are calculated inside the tool to find out the fate of a VOC compound in a wastewater treatment plant. So for a given wastewater treatment plant layout and influent loading of VOCs, you can estimate how much of the VOCs are going to go out in the air, how much of the VOCs are going to go out in effluent and the sludge. So it's a tool, basically, it's a predictive tool which can define the fate of VOCs in wastewater treatment plants. Toxchem has been used in industry since 1991. It has been an accepted tool for reporting emissions by EPA. It has an extensive set of unit processes that are used in wastewater treatment plants. Also, Toxchem contains extensive set of chemical compound database that can be used readily in modeling the emissions. It's a steady-state calculation tool. Just to let you know about the evolution of Toxchem, since 2011 we have been having regular releases of Toxchem. So we had our version 4, which was a major update from our version 3, which existed since 1991. We updated to version 4 in May 2011, and since then we have had, this is our fourth release actually. So we have released version 4.3 in July 2014. So in this webinar, we are going to speak about some of the new features that we have added in version 4.3. I've categorized the different features with respect to the unit processes, new models, and new functionalities. In the unit processes, we have added 7 new unit processes as listed here: membrane bioreactor, weir unit process, bar screen, water scrubber, floating roof tank, closed surge tank. Also, there has been a great demand about modeling emissions from oil layers. So this time in the new version we have added a functionality so that user can actually model the emissions from the oil layer. With respect to the new functionalities, we have improved our back solver functionality so that you can calculate actually the flows and other stream variables if you know the value of those stream variables at certain points in the layout, so you can back solve them. There is a facility for archiving the layouts. For example, if you create a new compounds in your layout, when you use the archive functionality, those new compounds becomes the part of that layout, and you can transfer your layouts to your colleagues. Also, we have added some other new features like quick adjust panel, in which you can adjust the property of chemical compounds. Also, we have air emission tables, a new table which actually provides you the summary of air emissions quickly. So I'm going to talk briefly about each of this in small details so that you can get an understanding of how these models are implemented in Toxchem. So the new unit processes, this is how they look: a membrane bioreactor, weir process, bar screen, water scrubber, floating roof tank, and closed surge tank. So with respect to the membrane bioreactor model, when you look at the icon, you will see there are actually 2 streams. One is the wastewater coming into the unit process. There is the airstream which you can feed to the membrane reactor. Wastewater is filtered through the membranes and comes out, and you can withdraw the sludge from this bottom connection here. The major difference between normal activated sludge system and the MBR is that a lot of scouring air is used to clean the membranes in membrane bioreactors. And the effect of membrane scour is modeled in the new model of the MBR to find out the extra emissions that you might expect in the in air. Also, MBRs are operated at higher molasses concentration, so you can expect higher biodegradation rates. And also, this unit process is equipped with a solid-liquid separation built into the system. So the philosophy we have chosen to do the MBR model is we have added a few new inputs into this unit process, which is basically the scour airflow rate. You need to define that, how much scouring air you're using, the scour duration. For example, if you're using it for 5 hours per day, it's kind of a frequency which you are defining in the model inputs. Also, we allow you to enter the oxygen transfer efficiency during scouring, which could be, by default, we have put a value of 5% here. Also, the sludge wastage rate. So these are some of the additional parameters which are required to model the emissions from MBR reactor. The philosophy we have chosen is basically we try to solve the model to estimate the emissions when the scouring is off. Also, we solve the model when the scouring is on, and then based on the frequency of scouring, we are estimating daily emission by doing a time average of the emissions calculated from step 1 and step 2. Also, we have added a new model, which is a floating roof tank model, and in this model, there is only one input coming in and one output. Of course, there is an emission coming out from this tank. While developing this model, we assume that there is no leakage from the roof, and the emissions are happening from the clingage on the peripheral wall. So, for example, when the roof is going up and down, there is a water layer or the oil layer which clings to the surface, or the peripheral wall which clings to the peripheral wall, and the VOCs in the clinged water or the oil layer gets volatilized in the air. So the inputs for this model, the important input is basically an exposure time, which is required to be defined by the user. By default, we have put a value of 1 hour per day. And the second important parameter, which is in the advanced tab, is the clingage thickness. So by default, we have set a value of 1 millimeter here. So this is a kind of a simple model which actually takes into account the clingage thickness and the surface area, basically, which is covered by the clingage, and based on that, it estimates the volatilization of VOCs. The next unit process is the bar screen model, and also it has one input and one output. The model basically considers the energy losses that takes place across the weir. So those head losses lead to energy dissipation around the screen and cause some turbulence around the area, which leads to emissions from this unit process. So in this particular process, the only user-specified input is the head loss across the screen. So if we look at the input screen for this particular object, the main important parameter for the process is the head loss across the screen, and by default we have set a value of 0.2 meter here. I'm not going to talk about the other remaining 3 unit process models. They are actually just the modifications of some of the existing models in Toxchem with a new icon in a sense. So we'll go to the modeling of the emissions from the oil surfaces, and this has been actually one of the requests coming to us from some of the users who have often wanted to model take into account the effect of the oil layer and how the emissions get affected due to that layer. So in this particular case, what we are trying to do is we are trying to differentiate the emission rates from a floating oil layer as compared to open water surface. And the main purpose of this is basically, in this particular case, we need to account for oil-water partitioning and oil-air equilibrium coefficient. So these are the two factors which probably are needed to model how much emissions are going to take place from oil layer. So the methods actually are not really very well defined for modeling the emissions from the oil layer, and that's why we actually chose to provide you with 4 different methods in Toxchem. So the first method, which we have implemented, is a standard EPA approach. So this comes from the Water 9 document, in which there is a procedure that is specified to model the emissions from oil layer, and it's based on Raoult's law. The second approach is basically we have tried to correct or modify the EPA approach by changing the equation with the Raoult's law with the mole fractions, basically mole fraction of the VOCs which are there in oil layer. The third approach, which is the Mantis approach and the default approach, uses the Smith number and the mass transfer rates calculated for the oil layers using the same approach as we use for the water surface, but adjusting it with oil-water partitioning coefficient and oil layer equilibrium coefficient. And the third approach is the empirical factor. For example, if you have some experimental data and you want to use that data in modeling the emissions from the oil layer, you can specify that empirical factor in Toxchem and use that for modeling your system. So just to highlight some of the important points of these approaches, in the standard EPA approach, we are using the Raoult's law, but in this particular implementation, the mole fractions are actually ignored in estimating the vapor pressures of any given specific compound. Also, the gas phase resistance is assumed, and the water phase resistance is ignored in the mass transfer coefficient calculations. And these two factors actually leads to a substantially higher emissions from the oil layers if we use this particular approach. In the modified approach, what we have done is we try to modify the Raoult's equation and correct it for the mole fraction of the VOC compound in the oil layer. And we think that this is a more correct approach to Raoult's law. And when we make this modification, the estimated emissions becomes much lower than what are estimated from the standard EPA approach. The Mantis method uses, like I said, it uses the same approach to estimation of mass transfer rates as we use for water surfaces, using the equation of McHugh and UN, in which we modify the density of the water to density of the oil and make the necessary modifications with respect to diffusion coefficients from water to oil, basically. So in this particular case, if we estimate the effect on the emissions, we estimate that 90% of the organic compounds result in lower emissions from oil layers as compared to water surface. And surprisingly enough, the Mantis method actually gives outputs which are very similar to the modified EPA approach here. So the outputs we are getting from modified EPA approach and the outputs we are getting from Mantis method, although they uses a different set of equations, they lead to very similar outputs. The third method, which is the empirical factor, it used in this particular approach, user can input a constant experimental factor and try to evaluate the oil emissions from the oil layer. And we also provide you the flexibility to define this correction factor for individual chemical compounds in the database. With respect to the new functionalities, as I said, we have improved our back solver. So some of the clients, earlier in the back solver, we were estimating the concentrations, the concentrations in the influent if you know the concentration at some particular point in the wastewater treatment plant. We were solving for the influent concentrations, but now you can solve for flow rates. For example, if you know the flow rates at certain point in the wastewater treatment plant, you can estimate what flows are coming into the plant from the influent. So you can do that now with version 4.3. Also, in the quick adjust panel, now we allow you to put the contaminant properties on the quick adjust so that you can modify the properties quickly and see the effect of those changes in the air emissions. Also, we have added a new air emission table which actually quickly provides you the summary of all the emissions all across the plant in a format which normally you would use to report your emissions. Another functionality is the archive layouts, which allows you to actually exchange your layouts along with the user-defined contaminants with your colleagues, and you don't have to worry about exchanging the database files. Also, we have made some changes to the database. So one addition is the chemical formulas. So for all compounds in the database, we have added the chemical formulas for each compound. Also, in the new version, we have added a temperature coefficient for Henry's law coefficient in the database. This was a hard-coded factor in the previous versions, but now you can actually specify the value for each compound in the database. By default, we have kept the value same as it was in the 4.2, but going forward, if you want to change the value of the Henry's law coefficient, you can do that. Also, we have updated the values, H values, Henry's value for ammonia and hydrogen sulfide. So these changes are based on some of the extensive literature review we did, and based on the outcome of that literature review, we modified the values. And the values actually have been scaled down. The values which were there in version 4.2, they were somewhat higher values for both ammonia and hydrogen sulfide, but the new values are kind of quite much lower than what they were in version 4.2. So I would like to give you a little bit of a demonstration about the changes we have made in version 4.3, just to give you a feel where to find these changes and how to look for how to use them in your layout. So this is a interface when you open the Toxchem. This is how you would see the screen coming out. One change you would notice is that we have added new information here, which is the emission for all contaminants. So as soon as you solve your layout, you can see the total emissions from the plant reflected here in this particular field here. So with respect to the unit processes which we have added, so 2 unit processes are there in equalization and storage. So you can see we have added a surge tank, a closed version, and a floating roof tank. These 2 unit processes are new. Also in the preliminary treatment, we have added a bar screen unit process here. For a biological treatment, we have a membrane bioreactor in our system now. With respect to air treatment, we have a water scrubber, and also actually another new object, which is an airflow converter from infinite to finite. So sometimes when you are modeling an open tank, then it's an infinitely ventilated stream, and if you want to convert it to a finite stream, you can use this particular object. Also, we have added the weir object in the miscellaneous tab here. So these are all the 7 new unit processes that are added in Toxchem version 4.3. With respect to the archive feature, if you go to the file, you can see that archive feature is there. So if you press this, it creates a new file which includes all the new contaminants which is added into the layout. So I'm going to just load a new layout here, and also another thing you would notice as soon as you load your layout is some change in color of the lines. So in this particular case, you can see that all the air emission lines are colored red here. And this is a new function which we have added to differentiate between different type of lines basically. And if you don't like the color scheme, you can go to actually view and preferences, and you can see these are the line colors, and you can actually go and change the colors of your liking. So you can change the color of wastewater, sludge line, air line, oil line. By default, these are the colors which we have chosen. With respect to the oil layer modeling, so if you go, for example, to the API unit process and right-click on the unit process, you will see that there is an advanced tab in which we have specified oil layer mass transfer coefficient, the estimation method, and we are specifying 4 methods here. By default, Hydromantis method is the default, and if you want to use EPA method, you can do that, or any of the other methods you can do, depending on your need there. So the oil layer modeling actually is available in a number of unit processes, for example, equalization tank. So if you want to see whether the oil layer modeling is available for a particular unit process, you can actually just right-click on the unit process and go to the advanced tab. And if you see this particular item in the advanced tab, then you may know that the oil layer modeling is applicable for that particular object. So this is the layout here, and you know that how to access the oil layer modeling. So now we are going to just, for example, if we solve this layout, we can solve the layouts, and like I said, immediately you get the total amount of emissions for all the contaminants displayed on this particular panel here. So now coming to the back solver changes, if we go to the back solver, you can see this new menu here, which is a stream state. And earlier we had only contaminants here, but now we have a stream state. So you can select for what particular parameters you want to use the back solver for. For example, if we use it for flow rate, and we say the flow rate for the DAF unit here is defined, and you can actually choose which unit process you want to choose. For example, we choose the DAF and the stream, and in this particular case, we want to say that, okay, to achieve affluent flow of 10,000 meter cube per day here, what should be the value in this oily wastewater here? So we can run that scenario and find some answers there at the end of the calculations, and these are the flows which it tells you to input in this particular oily wastewater to achieve a flow of 10,000 in the affluent of DAF. So you have quite a bit of flexibility here to run these scenarios for any chosen unit process on the drawing board here. So now the next feature which we added is with respect to putting the contaminant properties on the quick adjust panel. So this particular feature is available only for the user-defined contaminants. For example, we have a user-defined contaminant here, acetone user. So if I go to this one and I want to study the effect of biodegradation rate onto my emissions, then I can just pin this particular variable to the quick adjust here and try to evaluate the effect of this one. For example, if I run it with the standard parameter value, you can see that for this particular compound, you can see that 32% of the compound is biodegraded here. But if we change the value to, for example, a much higher biodegradation rate and run our system, we can see that 51% of the contaminant is biodegraded in the system. So this is a very kind of a quick and easy way for a user to actually manipulate some of the properties of the contaminant to see how well they reflect some of their major data, basically. Or if you have ever the need to calibrate your model, then this is one of the way you can actually do your study in a very efficient manner. Also, as I said, that we have added some new summary table, which is a air affluent summary here. So if you see the summary, it basically gives you the emissions for each particular contaminant in this air affluent here, and you can get the total of the total contaminant, which is the same as the value displayed here. And now coming to our last feature, which is the database changes. So if we look at the database, you can observe that we have added a new property called molecular formula. So you can see the molecular formula of the compound here. Also, for the stripping, we have added Henry's temperature coefficient. So by default, the value is 1.044, which is a hard-coded value, which was a hard-coded value in the previous versions, but now we allow you to have some control over this value. Also, for the oil-covered surfaces, when you're using the empirical method, this is the place where you're going to change the mass transfer adjustment factor. So with this, the demonstration is almost over for this one. And one extra news which I would like to inform you is a new Toxchem training course which we are doing with HSC University. And this is a course which will be happening on July 30th on Wednesday in Minneapolis, Minnesota. And if in this one, actually, we will be discussing about our standard training course for Toxchem for the users who need to understand a little bit more about the models, more about the workings of Toxchem. It will be a good opportunity to go and learn the workings of Toxchem. So if you're interested in registering for this particular course, you can go to this particular website here, https://illuminateyourbrain.com, and you can register for this training. With this, I would like to give the mic to my colleague Spencer to inform you some of the upcoming events at Hydromantis.